Our next speaker is a pure backend developer that started not hating front-end development so much since the advent of jQuery and fell in love with it since React, TypeScript, and NPM. Wouter loves everything IT and is especially excited about maintainability and documentation. Everybody please welcome Wouter van Schandevijl.
All right. Hello, everyone. I'm Wouter van Schandevijl, CTO at Itanium. We're a company founded by consultants for consultants. It's a Belgian IT consultancy, strong focus on improving ourselves while doing what we love, creating stuff. And this React component profiling is an extract of one of our workshops in the front-end track. So what's on the menu? First, we're going to talk a bit about the React profiler. It's pretty basic, but excellent at what it does. And then we're going to look at the real-world use case. It's our internal invoicing application, Config. And I put in there in memory, because at the startup of the program, we just load the entire database into memory in the front end and then work with the Redux store. And we're going to have a look at two different pages. The invoice lists, well, it's quite horrible. Before we start, it was 6 seconds for rendering 100 invoices or rows, so that's quite bad. And then that was actually the easy pickings. And then we're going to continue with the project months. Yeah, performance was even worse, with a worst case scenario of 10 seconds before the page became responsive again. And then if there's time left, we'll look at some alternatives to the React profiler, but probably that won't be the case. All right, so the React profiler, everyone probably already has it because it's part of the React developer tools. You can access it at the Chrome DevTools in the profiler tab. It has just a few buttons. You press the blue, not square, circle to start profiling. Then you perform the actions, you navigate to a different page, or perform another action, open a model or something. When you're done, you click the stop profiling, or alternatively, you can reload the page if you want to measure your initial load performance. And then if you performed multiple actions, you can switch between different render commits with the previous and next buttons. It features two different displays. The most important one, or the most useful, is the flame graph. Displays your entire tree. We'll have a few examples later on. And if you're lucky, if there is a clear performance target, it will just put it in orange, and you know where to work on. Typically, the flow is to run the flame graph, solve the performance problem, run it again. But at some point, the flame graph won't show you the next target, and in that case, you can switch to the ranked display, which might give you a better overview of where the next performance target is. So we start with the invoice list and some easy pickings. And this is, in fact, the flame graph of the profiler. So at the bottom, we're seeing the invoice worked days, which just displays a single number, and it's taking an entire second. And if we have a look at the application itself, so it's displaying just a number. It takes an entire second. So I started digging, why is it taking so long? And then we come up with the bottlenecks. It turned out to be a third-party package called Date Holidays, which we were using to calculate the Belgian holidays in a given month. The problem with the Date Holidays package is it can calculate holidays for any calendar in existence. So it's actually only 16 lines of code, but when you dig deeper, it's using a class, and then it's loading everything into memory. It's parsing 10 megabytes of JavaScript. So yeah, it was 10 megabytes to calculate Belgian holidays. So we replaced that with our own dedicated package, which was only 73 lines. So that was 1 second gone right there. Then we run the profiler again, have another look at the flame graph, and then the next performance issue turned out to be nested loops. So everything is loaded in the Redux store, we're looping over the invoices, and then we're doing a few inner loops to look up the details of the consultant, the client, the partner, etc. Of course, it's quite CPU extensive, but the biggest issue was probably that we were doing it for all the invoices and then just picking the one that we needed. So yeah, that was a huge optimization right there. But this nested loops will come back to bite us in the next screen, where we do need to have the loops for all the invoices. We ran the profiler again, and the flame graph told us it's the with claims decorator that's the issue, and that's actually an I/O bound problem, because all our icons, buttons were decorated or were wrapped with the with claims, and every time it was accessing the session storage, parse the JOT token, then see if you should see the button or not. So yeah, we just added a simple cache, and those 3 changes turned the performance from 6 seconds to 360 milliseconds. So that was good enough. But then we get to the meaty part. It's a project months, and the screen looks like this. So at the top we have 2 different months, and these are collapsed project months. We're just displaying a few numbers, and then you have a button to open the project months to see all the details, which is a pretty big inline editable grid. And so the problem there was every time you opened an extra project month, everything was being re-rendered. And if you opened everything, you were waiting for 10 seconds before you could do anything. Because of the previous performance optimizations, the flame graph was actually not giving us a clear performance optimization. So normally there is something at the bottom that's in orange, and then you can hover over it and see, yes, this is the issue. But that was no longer the case. But it was actually pretty straightforward to figure out. Because if you open or close project month, everything is re-rendered. This can of course not be the case, or the intention. And also, when we're rendering a collapsed project month, we just need to display a few numbers, but it was doing an expensive iFeature calculation, which well included all the inner loops. So what did we do? We started with the caching of the iFeature. And for that, we introduced a new library called reselect. It's commonly used with Redux to store the results of the computations. So it comes with the Redux.js toolkit. And how does it work? You import the create selector from the library. Then you define a new selector. So here is the create full project month selector that does all the inner loops resolving. And then you select the required store data. So here you have 1 or more arguments where you select the stuff you need from your store. You don't select everything, because then for every change the cache would be invalidated. So you only select the stuff you need. And then there is a specific syntax for reselect to how you introduce a parameter, because we want to do the caching for each month. So that's the first parameter is just the underscore as a state, and then you add one, and that's a parameter for your selector. And then the final argument is the actual calculation of the actual computation. So you get a function with, in this case, 3 parameters. The first 2 ones, the projects and the consultants we selected from the store, and then our extra argument, the month. And then it's the projects map is just some dummy code. But this is not enough, the create selector. We need to use another feature from React itself, and that's the useMemo hook. And now we will be combining those two to actually cache the calculations for all the resolvements for each month. So we import the useMemo from React, and then we create our opened project month list component. which has just a single parameter, the month, that needs to be generated. And then we use the useMemo on our previously created selector. The useMemo has two parameters. So the first one is your calculation, your expensive calculation. The second one is the dependencies. In this case, it's just an empty array because we want to cache we want to do the caching for each month. So if you have a different user interface and you're displaying just a single project month, then you would provide an array with a month parameter. And then if you have a next and a previous button, it would then invalidate previous cache and build a new one. So here we need to cache everything. And then we use the memoized selector to actually get the data from our store, and we render the component. The combination of the create selector and use memo is actually enough to cache everything for our opened project months. Then we still have the collapsed project months, for which we're introducing the memo also from React. For the collapsed project months, we actually did the same create selector and use memo trick, but it was a different calculation because you needed a lot less detailed information. So the memo is also just to be imported from React. And here is how we wrap an existing component with memo. So you call the memo, then optionally you add parameters for which you want to do the caching, and then you wrap the existing component. And then our final project month list component takes also just the month parameter. We select from our store whether this particular month is opened or closed. So there is also a small difference. We refactor this out of the iFeature behemoth, so that the collapsed or the opened project months components are no longer dependent on the entire filter state, which was the case before, and also the reason everything was being re-rendered. So if it's open, we return the opened project month list we defined in the previous slide, and if it's not the case, then we render the collapsed project month memo. All right, and basically that was it to optimize the performance. So if we have a look at how the flame graph looks like right now, we have the left part. This is the project month that was already opened. So previously it was all being re-rendered, but now it's in gray, which means I don't really have to re-render this. Then the middle part is the project month we opened, so obviously it has to be rendered. And then also interesting is the third part, because we use memo, it's completely cached. It has really cached the results of the component. And it's also much smaller because we had a dedicated calculation instead of resolving everything. And after this optimization, if you opened the second or the third or the 18th project month, it all took the same time, so it was about 140 milliseconds. So what are the takeaways? Depend on as little as possible. It's very obvious, of course, but you easily depend on more than you really need to. And then, of course, unnecessary re-renders happen when they can be avoided. And also when you're creating low-level components, it's best to not depend on any state, but just work with props. And then, of course, cache expensive calculations using create selector and use memo, or cache the result of entire components with memo. And normally it's thank you, but since I have 1 minute left, we can dive into some profiler alternatives. And this is console time. Then you can do any kind of expensive operation and do an intermediate optional time lock, where you can provide multiple arguments. So the T1 I'm using here is just a unique index you have to use, so how the console time keeps track of your different timers. So you It provides a different ID for each timer you're keeping track of. Then we do another expensive operation, and we have a console. I'm seeing a typo there, time end. This is more for low-level profiling. Typically, the profiler, typically you won't be needing this. It's really for micro-optimizations. The profiler typically gives you it to use straight. There is also a profiler component from React itself. I'm seeing I'm running out of time, so here's the code. You basically wrap one or multiple components with a profiler component, and again, giving it unique IDs. Then you have an onRender function with a callback with about 7 or 8 parameters. And in this case, of course, it's totally useless because the profiler Chrome extension will give you better information than this. But if you're doing really micro-optimizations and you're having a lot of profiler components, and then you have to write your own aggregator renderer, then yeah, it can come in handy. Yeah, and I'm over time, so this was it.
That was awesome. Thank you.